This video is intended to give you just a brief overview and a walkthrough of how we took our Statistics 3032 Probability and Statistics for Engineer course online from a live course environment at the University of Central Florida. The basic problem we were trying to address is that we have some very, very large classes. We teach a lot of engineering students statistics every year in quite a few section offerings every semester. About 250 students in the fall semester in a typical session, and 150 to 200 in a typical spring session, as well as about 150 students in the summer. So this is a class offered pretty often in the department, and it creates quite a bottleneck for a lot of undergraduate students as they go through. We also have some limited classroom spaces. It's not easy on the UCF campus to find a room to put 250 people in for a 1-hour lecture 2 or 3 times a week. So with the program growing and the course being taken by more and more students every year, we made a decision to experiment and try out an online format for the class. In terms of instructional design, the new class has several features in it that we think promote online education very, very well. We're using a collection of overlapping readings to bring a lot of reading to the online environment where the students don't have lectures. We use a lot of online discussion threads to get our students to write and to think conceptually. A lot of problem-based homework every week. There are flipped lecture materials that are recorded as videos for students to watch, and there's a semester project that causes students to think through one of the more advanced topics in the course and bring it to bear on a semester basis. In terms of pedagogy, we're really looking for a constructivist paradigm here. We want students to go through the material and construct their own knowledge. Within the course, students from different engineering disciplines all take the same course. So we want to make sure that students are applying their thinking creatively and reflectively to practices within their engineering discipline as they go through. Likewise, Peter Drucker tells us that we need to have organized abandonment in our thinking. Creating a new online version of a statistics class gave us an opportunity to really rethink some of the material that was offered in our live class and the way we've approached our text in the past, to kind of let go from some of the things of the past that would be difficult and unnecessary to recreate in the online environment. So we're definitely looking for not just new modalities for offering this material, but potentially new ways to think about how to teach it as we approach the new class. This class has been designated a high-quality online course by the University of Central Florida using a set of criteria from the state university system that online courses can go through. We first achieved the quality course designation at the end of our first semester, and by the end of our second semester offerings, we had achieved the high-quality designation in the state catalog. The course starts with some overarching objectives. We've made sure that each of the objectives is actually an engineering objective and not just a statistical objective. So the ability to understand factors and their interactions and the regression relationships among the variables is really the key element of the course as we go through. Statistics is a means to engineer. Statistics is not the end of the course in and of itself. It's really the engineering that we're after. Every unit in the course also has unit level objectives that will take students through what are we going to cover in this unit this week. Basically, the units are weekly, except in the summer term when things are a bit accelerated. In terms of overlapping text, this course uses 3 basic texts. The first is the DeVore text at the top here. That's the standard text that this class uses even for its live sections. It's the primary text for the class. We also use Charles Whelan's book, Naked Statistics. It is a much lighter read, and it gives students an opportunity to read a simpler version and explanation of some of the more complicated points in statistics. We also use David Lane's NSF online textbook for statistics, where readings are required every week. And these 3 books overlap each other fairly heavily. The Lane text is nice because it doesn't require you to have knowledge of engineering or calculus. It just explains the underlying concept, and it's a much easier read. The Whelan reading each week then gives them some insight into the stickier point that week before they get to the DeVore text. So the rule of thumb in this online class is we tell students it takes less time to read all 3 reading assignments than it would to take just the DeVore reading assignment, because that reading is the most complex. Some students want to jump to the DeVore text because that's where the homework is, but generally the students that try to do that report that the readings actually take them longer and their understanding is not as good. So given that students are not coming to class twice a week for a live lecture, the extra reading causes them to think about the material in a more dynamic way, much like they would if they were trying to take notes during the discussions in a class. The individual discussions, there are 37 of them throughout the 15 units, are all graded using the same 40-point rubric, which assigns basically 20 points to the initial posting and 10 points each to 2 other postings that they do. So for each of the 37 discussions in the class, students do a total of a minimum of 3 postings per thread as they go through. Sometimes those threads are an interaction with the instructor, going back and forth and digressing into the topics even deeper, or asking questions about the topics where the instructor does the majority of the responding. Other times, students are simply interacting with each other, discussing the concept that's been presented for them in the prompt, and that a discussion like this might have minimal instructor involvement. We use the DeVore text, which gives us access to the Cengage WebAssign tool. So as a weekly homework gets done in the online environment that does the grading, the instructor is able to monitor the work being done through the week and see where some of the weak points are. So here's an example from the Unit 5 homework. This is a snapshot of the material in midweek. It shows the basic questions there on the left, and you can see that the first few questions are getting answered correctly by some of the students on a first, second, or third attempt. That's the different green shadings. The last 2 questions, though, students are either getting it right the first time or they're not getting it right at all. So I can see, looking at this by midweek, that I might want to go in and spend a little extra time in the discussions, or perhaps even worst case, produce another lecture video that will support some of the material going on in those questions 87, 88, and 90. It's usually the latter half of the lesson that the students are weak, but the instructor has visibility into how students are doing their work as they go through. This tool would be more useful if we could get students to do their homework farther in advance. Note this is a snapshot of the homework the day before it's due, and fewer than 25% of the students have actually done the homework at this point. But as a diagnostic tool for where students will struggle or where they are struggling, even that 25% can be quite insightful. Other times we record basically DocCam style videos that illustrate some of the main concepts. So here's an illustration video of an alpha beta risk being discussed and the way the beta risk tends to vary as we go through some of the calculations. This was an actual example from the text that's being discussed in the video, so students can go back and forth to the text to see what's happening in that particular example in DeVore. Sometimes those examples work better if we move them into Excel to show slightly more complicated calculations. We can go a little deeper than the exercise does in the class. Again, this is an example from the DeVore text on page 318, so students can go back and revisit and reread that material and rework that problem as they go through. So between the DocCam videos and the Excel videos, most of the material in each of the chapters is demonstrated to students in recorded lectures each week, much as it might have been in a flipped classroom environment where we work in a live class working problems. Some examples of the ways we've made some of these changes in the teaching of the material are very, very important in terms of Druckers' concept of organized abandonment. One of the things that we've always struggled with in statistics is the reliance on choosing significance levels for our alpha using tables in the back of the textbook. If you have to use a table in the back of the textbook, you're only going to see alpha as a potentially discrete variable, usually 1%, 5%, or 10%. And then later when we move on to alpha, beta, and we try to teach our students that they should be willing to accept the highest level of alpha they can in order to minimize beta risk, we're asking them to think of alpha as a continuous variable after several chapters where it's been ingrained in their mind to use discrete variables. How do we get students to think of alpha as a continuous variable that they haven't in the past? And one of the ways we do that is to move them into Excel. So notice that in any statistics book, you've got a series of tables in the back usually where students can look up the probabilities and t factors associated with given alpha levels. So 1%, 5%, 10%, sometimes, and in this case, 0.1%. That really limits their thinking. If in the alpha beta discussion we find out that the optimal risk for a given project would be an alpha of 3.5%, our students can't look that up if they're using the tables in the back of the book. So if we really want to use statistics for engineering, we have to let go of this notion that probabilities are things to be looked up in tables in the back of the book. So again, rather than looking it up in the tables, we encourage students in this class to use Excel and to use Excel heavily. There are other statistical tools out there. Minitab is one that comes to mind for a lot of students. We do not encourage the use of those tools, largely because you can use those tools without understanding the underlying statistics. Too many checkboxes and things you can fill in. Typically, we find that for students to use Excel, they have to understand the statistics in order to build the spreadsheets appropriately. So just like using the tables in the book, they have to know what they're doing, but they don't have to do the exhaustive calculations as they go through. So we teach them to use Excel to look up their factors, and they get a more accurate number in the long run. If you're engineering on tight tolerances, you want those decimal places. So rather than 95% confidence with a degree of freedom being a T of 2.262, we want them to know the actual value with more decimal places as they go through. So rather than looking things up in tables, we're encouraging them to use spreadsheets as they go through. We think that is just good statistical teaching to begin with, but it also aids some of the assessment activities in an online class where we want them to turn in and show their work. We can't see for students that aren't in class whether they're looking at the table correctly or not, but if students are turning in their work, turning in their spreadsheets, we're able to look at the spreadsheets and see if there are any problems related to how they're using some of these basic functions. When we're teaching in a video kind of format, here's me teaching one of my lectures, I can get into a very traditional construct. So some of the online course environment starts to look like a live course environment for those few times where how something is drawn on the whiteboard, or in this case, how it's drawn on the glass board in front of me, is an important part of the lesson as they go through. So once in a while, we use actual videos of ourselves teaching the lessons because the drawing of the picture, the active seeing of it happen as things unfold on the video are an important part of what we want them to learn as they go through. So to understand, in this case, the relationship of the alpha, in this case 0.01, to the effect on beta and where that falls within the curve, and how changing to an alpha of 0.05 dramatically reduces the beta risk as they go through, are visual things we want them to see. And so sometimes the videos are just built around the way we would have lectured about this material, even in the live class. Other times we can demonstrate very similar kinds of expertise using the DocCam style of video that you see here. So here's, again, an example from DeVore going through the same alpha-beta concept with an alpha of 0.01 versus an alpha of 0.05. So you can make some very good points using the DocCam, but every once in a while you just want to stand in front of the class and give the lecture in that way. So we've got a combination of videos as you go through the different classes, substituting for what would have been the traditional pedagogy of the live classroom. But ultimately, it's all about teaching those kinds of relationships. We want students to understand that alpha is a continuous variable that can be optimized against beta, and that the 0.1, 0.05, 0.99, the discrete alpha values are not what they should be concentrating on. Alpha is a continuous variable to an engineer. Teaching the normal approximation is another way, another example of how some of the ways we teach some of these things differs if we can move them into spreadsheets as we go through. Because we tend to require students in statistics, in a traditional statistics class, we've always required them to do a lot of the calculations by hand. Calculate a binomial or a Poisson distribution, and then we teach them that as n increases, it can be much easier to use a normal distribution to approximate the binomial or the Poisson. And that makes a lot of sense if you're calculating things by hand. But typically, we don't want to lose that precision unless we really need to. And today, in modern statistics classes, there's no reason to teach that form of approximation. So the binomial distribution, indeed, as n climbs, does in fact start to look like a normal distribution, and we want our students to understand that. But when it comes time to working problems, we don't want them calculating some of these things by hand. So here is a sample of 200 with a success probability of 60%. What's the probability of finding 125 or fewer successes? So when you fill in the equation for that, you don't want students doing this by hand. Plus, this is a discrete probability curve. They wouldn't just calculate this for 200. They've got to do it for all the different values from 0 to 125, and no student can be expected to calculate this by hand. So instead, we teach them the approximation where we can calculate z and use the normal curve in one step to get to our probability. But the reality is I can do both of those things very quickly in Excel. In fact, it's easier to enter the binomial probability than it is to do the normal approximation because I don't have to calculate s in my limits in and apply the continuity correction as I go through. So since it's easier to do the binomial calculation in Excel than it is to do the approximation, and the answer is more precise, we really don't want to have our students using the normal approximation for this. We want them actually calculating the true probability using the distribution that they were taught in class. The Poisson distribution gives us the same basic effect. As n increases, it looks more and more like the normal curve. So we can give them a problem like 1,000 widgets being created and ask the probability of seeing 990 or fewer or actual successes. So again, we plug the numbers into the formula. We recognize as a discrete calculation, we really should be doing a summation, which nobody would want to do by hand. So we've always, again, taught them how to do the normal approximation to get their value using the normal curve. But again, they can get that answer just as easily and easier doing the Poisson calculation directly, where they don't have to stop and calculate z or apply the continuity correction as they go through. So by applying the right tools, we can let go of this notion that the way we should teach statistics involves a lot of hand calculations as we go through. We do want to teach them the relationships between these distributions because that's still needed. Our engineers are going to go out in the field and work with people that were taught to use the approximation, and that approximation comes up in the literature very, very often. So we want to make sure we teach this diagram and teach the relationship among these distributions, but that's different than causing them to rely upon the approximations as ways to get answers, given that the tools that they use are so effective nowadays in Excel and other statistical packages that they're very likely to run into in the workplace. Okay, so we want students to be exposed to these distributions, but basically teach it as history, talk about how the approximation was used. We often talk in terms of the tables in the statistics book as ways to be able to do this expression before we had spreadsheets and Minitab and tools like that to do our work. But we're dealing with students who are now digital in their age. These tools have been around now for decades. You know, we wouldn't hire an engineer that didn't know how to use Excel. So why do we keep insisting that students don't use these tools to take their exam? In essence, we're forcing them to use shortcuts that really don't, for problems we actually no longer have anymore. And we need to teach things up to date as we go through. The counter argument to that we often hear is if you're thinking that if we don't use the appendix tables, how will we test our students? Won't they cheat on the exams if we tell them they can use Excel? Well, you have to kind of ask yourself, what is it we're trying to teach and assess? Are we trying to teach their ability to solve some equation in arithmetic, or are we trying to teach them how to think statistically? So automation in Excel allows us to assess much more complex and authentic scenarios. And that's really the key here, is you have to know the stats to build the spreadsheet. And if you're using a spreadsheet, you can do a much more realistic type of problem. So here's a sample exam question from the class that if students had to hand calculate these probabilities, particularly using the approximations, there is no way I could use this kind of question on a class exam. But this type of question where we apply Poisson and binomial and Poisson and exponential, we apply all different distributions to the problem of predicting how likely you are to take a multi-flight itinerary and get to your destination on time. So we end up with a solution that looks like this when students are done, and it's a little over 84% is your probability. But there is no way I could give this kind of assignment in a class where I expected students to do the exams by hand. It's only with the automation of Excel that I can give them this kind of problem. So we've always given them problems on binomial. If you can make 10 widgets, what's the probability of having 4 defects? And that can be calculated by hand, but it isn't a realistic example. This is a much more realistic example. It involves the interplay of different variables. It involves a joint distribution, and it involves applying logic to the problem and making sure they understand what these distributions would be used for. This one question is a very thorough assessment of how well they understand the distributions, basic theory of probability, and how to do joint distributions as they go through. It's an excellent question that couldn't be asked if we weren't allowing them to use Excel to create their solutions. Additionally, beyond all the homework types of assignments and different ways we do lectures, the class also includes a video project assignment where they have to do in week 14 a video project where they record an explanation of a relatively simple topic related to ANOVA or regression. ANOVA and regression are the advanced topics in this course, and for students that go forward to Stat 2 or empirical methods, they'll get a lot more of that. But this video project makes sure they've at least had some exposure to that material for those that will not go on to take more statistical lessons. Likewise, there are 4 formative assignments that students work on. They pick the topic they're going to work on in week 6. They produce a storyboard in week 8, a script in week 10, and a promotional flyer in week 12. So here's what one of the storyboards looks like from a student who gave me permission to use this material. It's basically 3 slides where they just mock up the kind of material they're going to use and the way they're going to talk about their statistical topic as they go through. Later in the semester, they have to create a promotional poster for their video as though they were trying to advertise it as a movie people could come to see. And this is the example from a student, again, who gave me his permission. And then lastly, they actually turn in a YouTube video at the end of the semester, which I watch. It's anywhere between 1.5 minutes and 3 minutes. And most students do a really, really good job on this. Some are more creative than others, obviously, but the video causes them to really think through not just what is the topic, but the video has to show how they would apply the topic to an engineering question within their chosen discipline. So given that all of our students are from different majors, they're all attacking the topic in a different way, applying it to their engineering major. And then finally, throughout the semester, there are 6 extra credit essay assignments that try to challenge students to think in terms of critical thinking beyond their readings and beyond their problem solving, making sure they're thinking like engineers as they go through. This particular one, they have to read Plato's Republic and apply the allegory of the cave from book 7 to use it to explain what's really happening when they do statistics, what's happening in engineering when we do that. About 1/3 of the students in the typical section participate in the extra credit assignments as they go through. So thank you very much for listening. Here are the references that were cited up above that you can use to get into some of the pedagogy we've built into the course material.